Hi everyone, welcome to my YouTube channel Tutorial Home My Electrical. In this video, I will going to discuss a series against top 100 question of measurement. If you like this video, please like, share and subscribe this video with your friends. And if you want notification regarding my channel, please press the bell icon. So let's start today's video. In today's video, in first question said that a voltmeter has a uniform scale of 100 division. Here is a scale. The scale has 100 division. This is 100. Okay, this is 100. The full scale reading is 10 volt. Here is 10 volt and here is 0 volt. Full scale reading could be read up to 1 by 10 of scale division. 1 by 10 division can be minimum read by the measuring instrument. They asked its resolution. Okay, so the resolution means the minimum quantity can be measured by the measuring instrument. So we can say here that 100 division means 10 volt, 1 division means 10 by 100, 0.1 volt. 1 by 10 division minimum division can be did by the measuring instrument. So 1 by 10 is 1 by 10 into 0.01, so 0.01 volt. 0.01 volt can be measured by the measuring instrument, so the resolution is 0.0 volt. Option C is correct. So going to the next question. In next question 3, here 3 DC voltmeter is connected in series across 120 volt DC supply. The voltmeter are specified as follow: 3 voltmeter A, voltmeter C and voltmeter B and voltmeter C is connected across a 120 volt DC supply. Okay, the specification of voltmeter A is given. They given on 100 volt and the 5 milliampere. Here 100 volt is VFSD of voltmeter A, and it is given the IFSD of voltmeter A. The specification of voltmeter B is 100 volt. 100 volt means VFSD of voltmeter B, and the 200 volt it is the sensitivity of voltmeter B, and for the specification of voltmeter C is it is IFSD, and it is the 15 kiloampere. 15 kiloampere is the internal resistance of voltmeter C, means RC is given. So the question asked that the voltage reading by the meter A, B and C are respectively, means 120 volt. The source is 120 volt. In 120 volt voltmeter A measure what voltage can be measured by voltmeter A, and by voltmeter B what voltage is measured by voltmeter B out of 120 volt. Voltmeter C, what voltage is measured by voltmeter C. If we calculate the internal resistance of voltmeter A and B and C, we can be measured by the voltage drop against voltmeter A and voltmeter B and voltmeter C. Then the voltage drop, we can calculate voltage drop against voltmeter A and B and C. So we can tell that what voltage can be measured by voltmeter A, voltmeter B and voltmeter C. If we calculate the internal resistance of voltmeter A, voltmeter C, B and voltmeter C, by the internal resistance we can calculate the voltage of against voltmeter A and voltmeter B and voltmeter C. This is the voltage measurement by the meter A, meter B and meter C. So let's start calculating the internal resistance. For voltmeter A, we have to calculate the RA. Okay, for voltmeter A, VFSD is, for voltmeter A, VFSD is 100 volt. And the IFSD is 5 milliampere. Okay, 5 milliampere. So RA is equal to VFSD by IFSD. So here VFSD is 100, it is 5 milliampere. 5 into 10 to the minus 3. So 20 into 10 to the 3 ohm. Ohm means 20 kilo ohm. So internal resistance of RA, internal resistance of voltmeter A is RA equal to 20 kilo ohm. Okay. Now we are going to calculate the internal resistance of voltmeter B. So RB, for RB, VFSD, what is the value of VFSD for RA? For RA, VFSD 100 volt and the sensitivity is 250 volt. It is 100 volt and sensitivity is 250 volt. Okay. So RB equal to VFSD by IFSD. We know the sensitivity SB equal to 1 by IFSD. So okay. So VFSD into SV. What is the value of VFSD? What is the value of VFSD? 100 volt and 250 ohm per volt. Okay, means 250 into 10 to the 3 ohm means 25 kilo ohm. So we have calculated the internal resistance of voltmeter B. Now we have to calculate the internal resistance of voltmeter C. Internal resistance of voltmeter C is already given. If we notice the question, the voltmeter internal resistance of voltmeter C is already given. So here a C is already given as 15 kilo ohm. So now the question is, like 3 internal resistances connected across 120 volt. So here is 20 kilo ohm, here is 25 kilo ohm, here is 15 kilo ohm. Okay, it is RA, it is RB, it is RC. So if we calculate the current here, we can calculate the voltage drop against each resistance. This voltage drop is against each resistance is the voltage measured by each voltmeter. Okay, so I equal to 120 volt by 20 into 25 plus 15 into 10 to the 3. Okay, so 120 divided by 60 into 10 to the 3. 2 by 10 to the 3 means 2 milliampere. So the current is 2 milliampere. So here the current is 2 milliampere. Here the current is 2 milliampere. So here the current is 2 milliampere. It is 2 milliampere. So the voltage of VA is equal to 20 kilo ohm. 20 kilo ohm into 2 milliampere. Kilo ohm and milliampere is cancelled, so here the voltage drop is 40 volt. Like similarly, voltmeter by voltmeter B, 25 into 2, so 50 volt. By voltmeter C, 15 into 2, 30. Okay, 30 volt. So the correct answer is 40, 50, 30. 40, 50, 30 means option number A. 40 volt is measured by voltmeter A, 50 voltmeter B, and 30 voltmeter C. Okay, now we are going to the question number 3. We are going to the question number 3. In question number 3, what is said in question number 3? In question number 3, they asked match list 1 type of the instrument and list 2 suitability for measurement and select the correct answer using the code given below in the list. Means in list 1 the type of instrument is given with the code capital A, B, C and D, and in list 2 the suitability for measurement is given in the code in 1, 2, 3, 4, 5. Okay, now we have to calculate, we have to choose correct option which said the correct matching with list 1 and list 2. Means capital A, B and C, D with 1, 2 and 3, 4, 5. Okay, like in option number A, capital A is with 2, B is 4 with 4, C is 3, D is with 1. Similarly, in option number D, capital A is with 1, B is with 2, C is with 5, D is with 3. Okay, we solve the question with the option elimination method. If we see here by induction, capital C said induction type of instrument. We know that with induction type of instrument we can calculate only AC. So option number, now see the option. In option number A, capital C is with 3. 3 means AC voltage or current or power. AC. Only AC is only AC. Only AC. Option number C is, option number 3 is means 3, code 3 is only AC. So in option A, C is with 3, and in option C is with 3. Okay, so option number A or C will be correct. Now we have to eliminate between option number A and C. For this, we going to the capital A, as in option number A, capital A is with 2, and in option number C, capital A is with 1. If we decided which is correct for capital A, and so then we can eliminate option A or C. Okay, so if we go to the capital A, it's a moving ion. We know that moving ion deflection is proportional to measuring input as square, Vm or Im square. Okay, Im square. So here AC and DC can be measured. AC and DC voltage or current can be measured by the moving iron. So option number A said, option number in 1, AC and DC voltage, only voltage. So option 1 is not with capital A, and option 2, here 2 code is AC and DC voltage and current only. So capital A is with 2, not 1. Now we see the option. In option A, capital A is with 2, and capital in option number C, capital A is with 1. So the correct answer is option number A, as it is correct. Capital A is with 2. 2 means AC and DC voltage or current only. Okay, so we can eliminate option number C. So correct answer is option A. So now we, for your knowledge, if we tell option number A, for option number A 2, option number C 3. Okay, option number C is for 3, option number B is for 4, option number B is for 4, and option number D is for 1. So let's see, for by moving iron we can calculate 2 means AC and DC voltage current only. By electrodynamic, capital B, we can calculate 4 AC and DC voltage current and power only. Electrodynamic, power only. Okay. Option number C, induction. By induction, we can measure only AC. So 3 AC voltage or current powered only. Okay. Now capital D, electrostatic. With capital D, we can measure AC and DC voltage only. Electrostatic, we can calculate voltage only. Okay. So D for 1, C for 3, B for 4, A for 2. It is correct answer. So the correct answer is option number A. Okay. So thank you for watching today's video. Thank you for watching today's video. We can discuss the next question in of part 2. If you want the notification of part 2, please press the bell icon. Thank you again. So let's bye till then.